Hey, now you're welcome to my channel. Now right here in this video, we want to solve for the following functions. We want to find the derivative of the exponential functions. We have it first to be e to the power x, and when we're talking about derivatives, you know what it means, right? We're talking about the gradient of a function. So the derivative of a function is the gradient of a function at any point, but here we are not given some point. Now, this is just the derivative with respect to x of e to the power of x. Now, this right here is the answer. It is just e to the power of x. It doesn't change, alright? Okay, how can we show this? The main thing here is just to prove to you that all of this right here is true. Show you the necessary steps. Okay, here we go. Now we start by simply saying let y be equal to e to the power x. By making y to become the function right there, right? In order to reduce complexity of using f of x, yes, f of x as a rule. Here we have y equals to e to the power x. Now if you go ahead and take the ln on both sides, the natural logarithm on both sides, in order to reduce this, alright? The natural logarithm is actually a logarithm with a base e. So if you take the natural logarithm on both sides, you're going to have ln of y is equals to ln of e to power x. Like I said, the ln shows logarithm to base e. So if we are saying logarithm of e to power x to base e, it's actually the same thing as saying, from the logarithm property, we bring this x back like this, we have ln of e. Ln of e, that is log of e to base e. This number here is the e. This alone has the base e. This is the same thing as saying 1, right? Log of the number to the same base, the number is in the base and the number there, so we just have it to be 1. And right here, we're going to have ln e to be 1. Therefore, we have that ln y is equals to x times 1, that is just x. Okay, and here, we can go ahead and say, okay, let's do some differentiations. That's the next step, we differentiate. So the derivative of ln y, well, this is an implicit function. We're going to have the derivative of ln of a function of y is going to become 1 over that function, and we multiply it by the derivative of y with respect to itself. That is going to give us 1, right? And again, since this is an implicit function, y is a function of x, then we're going to just put down right there the y dx. And this is equal to what the derivative of x with respect to x is just giving us 1. And right here, what we now have is, well, here we can just go ahead and say, multiply y on both sides, we're going to have that the y dx is giving us y. And what is y? Well, y is equal to e to the x, so the y dx is equal to e to the power of x. And that's it. So we are done like this. Alright? Okay, over to the next question. We have to differentiate e to the power x times tangent x with respect to x. And this right here is the answer. Let's just get on with it. Now observe that here we are having a product. So if you call that y, if you call this y equals to e to the x times tangent of x. Okay, like this, alright? Then I'll go ahead and say, since on the right hand side we're having a product, let's just go ahead and find the derivative of y with respect to x. And since we have a product here, you're going to make use of your product rule, alright? So we have the y dx is equal to, well, e to the power of x times tangent of x. We're going to have, well, first, your product will be having the derivative with respect to x of u times v, where u and v are functions of x. We can have this to be u dv dx, okay, plus v du dx, like this, alright? So you keep the first function, you differentiate the other one, you add it with, you keep the second one, you differentiate the first one. So here we just have to keep the first one e to the power of x, and we differentiate tangent of x. Well, the derivative of tangent of x is secant square x, where secant is 1 over cosine, right? Secant square x is the derivative of tangent x. So we have secant square x. We add it with addition Now, since we came to the first function the other time, we differentiate the second. Now we're going to keep the second, that is tangent of x, following this rule, right? And we differentiate the first. Well, the derivative of e to the power of x, we just did it right here. And what did we have? We had e to the power of x. So the derivative of this man right here still remains the same. This is the only function that is equal to its gradient. So that is e to the power of x. Well, here, since e to the power of x is here and here, therefore it's common, we can factor that out. We have e to the power of x times secant square x plus tangent x. And like this, we are done. Oh, well, here is tangent x and square x. You know, it's addition, so it's commutative. You can either write this like this or the other way. But this is the correct answer. Okay, over to this one right now. We have here to be the derivative of x times e to the power of x and x squared. This right here is the answer, so we're going to show that this is true, alright? Okay, first, like we used to do, we take y to become the function. So let's say that y is equal to x times e to the power of x squared, like this, alright? Very nice. Ooh. Well, as a product, it is just like this one. We're having product of two functions, so we're going to go ahead and apply the product rule. We have that dy dx is going to become, well, here we keep the first function, we differentiate the second, and what is the derivative of that man respect to x? Well, we're going to come back to that, alright? We add it with, now we're going to differentiate the first one while keeping the second one. So we have e to the power of x, and to the second power, we find the derivative respect to x of x. Now here, we're going to just find the derivative respect to x of e to the x to the second power. Okay, very nice, like that, huh? Here, I can decide to call this a function of a function, okay? So, if we say, okay, let u, we have the derivative respect to x of e to the x to the second power. Well, let u be equal to x squared. In that case, y will now become e to the second u, alright? If u takes this place, we're going to have y to be e to the u. And du, the x, is also equal to what? 2 times x. So if you apply our chain rule here, for us to apply chain rule, we need to know what is the y du. So the y du is going to become still the same thing, just like this, right? This one is in terms of u. So to apply the product rule, we're going to have the y dx is equal to the y du times du dx. And this right here will give us the y du, that is e to the u times du dx, and that is 2 times x. Okay, so what was u? Well, u was equal to x squared. We can just take this out and just put right there, x squared. Now we have e to the 2x, sorry, u was x squared. This is x squared like this. So we have e to the x to the second power times 2x. Okay, so that is the derivative of e to the x to the second power. So we just bring that in right here. We're going to have x times, well, here is this times 2x times e to the x to the second power plus, here we can just have this out like this, x to the second power times, well, the derivative of x with respect to x is just 1. There's no point, right? Okay, here we can just do some factoring. We're going to have, okay, let's first of all multiply this so that it will look like that before I do some factoring. So here you just have 2x squared and e to the x to the second power plus e to the x to the second power. What do you observe right here? You observe that this is identical to this one, and this one is identical to this one, therefore they are the same. But we can go ahead and do some factoring like this. Since e to the x to the second power is common, we have 2x squared plus 1, and that is it. Alright? Okay, so over to the last one, which is the number 4. In fact, I will allow this for you to do this one. I'll leave this one right here for you guys to do it. This is just x, and this is just negative e to the x. This right here is the answer, 1 minus e to the x power. I believe you can do this right. Okay, thanks for watching this video. Please subscribe to this channel.